Hello everybody, welcome to our lab presentation of Nothing But a G Thing by Richard, Mercedes, and MK. In this lab, our goal is to conduct a study of free fall motion, as well as its acceleration due to gravity, and how we can measure it with various means of success, failure, and uncertainty. By using kinematics to analyze each test of motion, we are able to determine their gravity. For example, when using the tracker, we were able to determine an average gravity between the group of -9.32 with a plus or minus of 0.12 uncertainty, and of course meters per second squared. With Firefox, we were able to calculate a 10.16 negative gravity with plus or minus 0.02 uncertainty meters per second squared. And with the stopwatch, we were able to determine 2.33 plus or minus 1.78, being our lowest accurate form of testing gravity.
The goal of this experiment was to determine the acceleration due to the gravity using the measurements method, stopwatch, smartphone via Firefox, and the tracker video analyst to compare their uncertainties and to analyze the sources of error that affect each method. Procedure. For the stopwatch method, the ball was dropped from the measured height, and the fall time was recorded with a stopwatch to calculate G. In the Firefox method, a smartphone recorded the acceleration during the free fall, and G was determined from the data. In the tracker method, the video of the falling ball was analyzed. Position were marked frame by frame.
In the Firefox method, a smartphone recorded acceleration during freefall, and G was determined from the data. The error margin for this method was smaller, random uncertainty, and a scatter between trials.
A parabolic fit of the y versus t, which measures time, and which we were able to provide the acceleration with which we could determine gravity, using the equation of y equals at to the power of 2 plus bt plus c. And with so, we were able to determine the gravity of our group to be an average of -9.32 plus or minus an uncertainty of 0.12 meters per second squared. As well as using the formulas below and the app called Tracker, which the data has been shown on the right.
The physics principles we used were the 1D kinematics principles to understand the gravity of the tennis ball, along with multiple trials of different measuring methods, such as the Firefox, the tracker, and the stopwatch. We also used principles from the uncertainty values and to calculate G. Results of the experiment. As a result of all the components of the experiment, we estimated the gravitational acceleration of the tennis ball to be 9.32 with an uncertainty of 0.12 meters per second squared.